All right, so I want to show how to do a Mann-Whitney test on some data that I have here. This is bee abundance on native and introduced plants. So you can see there's the plant species, the common name, the bee abundance, how many bees there were per meter squared, and then the plant origin, whether it's native or for N or introduced, which is denoted by I. So what we want to do is sort this out so that we're going to see the introduced bee abundances first and then the native bee abundances. And we're going to be able to do a comparison. So we're going to do an advanced sorting, and you're going to click data has header row. You can put in the plant origin, and when you click it, it's now sorted it by putting all the introduced or I's together and all the natives. And you can see that some don't have any plant origin. That's likely because there was both introduced and native species in that group. So we're just going to look at the ones with a clear delineation. We're going to copy that data and then bring it over into Stats Kingdom. And we're going to first test the normality because that is one of our assumptions for using a t-test. So we're going to copy in the data, cleared out that data, and then hit calculate. And you're going to see here a p-value less than 0.05. That means there's a significant departure from normality. So the data is not normally distributed. And so that's starting to give us an inclination that we cannot run a standard t-test. So let's look at the native data. We hit calculate. We copy it in for both of the data sets, introduced and native. We see again, it's departing from normality. So in this case, we really need to think about what is the proper statistical test. And the Mann-Whitney test can be used to analyze this data because it does not assume that the data is normally distributed. So Mann-Whitney is very useful. Let's set it up here. We've got our alpha of 0.05, and we're going to try and get our p-value all set here. So we go down, we're searching on the for the two sample Mann-Whitney U-test, and we found it there. So we're going to click on it, and we'll see that there's an alpha you can specify, but just most cases leave it 0.05. And I had already actually put in the data, but I'm just going to show how you can do it here. You're going to select down the introduced and just kind of double check, make sure you're doing this accurately, copy and paste it in. Do the same for the native data, bee abundance, and then look at it all and hit calculate. So you're going to see the sample averages and sample size. You can cross-reference this with your data sheet. It's always good practice. You see the standard deviation, a lot of good descriptive statistics there. And then you see the normality that we actually already ran with the Shapiro-Wilks. So there it is again in case you didn't believe it the first time. You see the p-value, it was 0.9882. So that is higher than 0.05. We fail to reject the null hypothesis, and there is not a significant difference in the bee abundance on native and introduced flowers. So maybe not what we had predicted or expected, but that's what we got, and that's the power of statistics. So you can look through the rest of this. There's some figures and some information on test validation, outliers. Again, I don't recommend removing any outliers unless you have a great reason to do so, like you think it was an error. So some good options there from Stats Kingdom on the Mann-Whitney test. Hope this is useful.